Okay, so here is the video for sections 1.4 and 1.5. They do really run together. 1.5 is just basically the applications of the topics that we are going to cover in section 1.4. So here we go. When solving quadratic equation, there are four basic methods. There are these two orange ones, which are using the zero product property by factoring and using the square root property. And the thing about these two is that they do not always work, okay? The thing about the green ones, completing the square and using the quadratic formula, is they're always going to work. Now, I will put one more caveat in here, which is why I have an asterisk, which is this. Completing the square is not the most user-friendly way to solve these. But completing the square as a skill is something that we're going to need later on in the semester. So I will we'll go ahead and show you how to do that here, and we'll talk more about that when we get there. But first of all, let's talk about this zero product property. So the zero product property basically says this. If you multiply two things together and the answer is 0, that means that one of those two things has to be 0. Okay? There's no way to multiply two numbers together and get 0 unless one of them is 0. It just has to be that way. So we're going to use that to our advantage down here when we're looking at factoring these. So if we look at number 1 here, I've got x squared plus 2x minus 8 equals 0. And so if you are, rusty on factoring or things like that, there are plenty of places where you can go and find videos for practice. I'm going to show you the way that I do it and kind of move on from there. So I'm looking for the factors of a negative 8 that are going to add together to get me a positive 2. And that will be a positive 4 and a negative 2. So 4 times the negative 2 gets me the negative 8, and 4 plus a negative 2 gets me the positive 2. So this is the correct factoring of this trinomial. So the thing that we're going to look at here using this zero product property is I've got this factor times this factor, and the answer is 0. So the zero product property tells me that one of these two things has to be equal to 0. And so I will solve for each of these, and I get two answers, okay? Now, these are my two solutions. Remember, a solution is a number or numbers that make the original statement true. So what this means is if I put in, let's say that I put in the 2 here, okay? I'll do it in this color. If I put in a 2, for x, I get a true statement because that's 4 plus 4 minus 8. Well, 4 plus 4 is 8, and 8 minus 8 is 0, so this gets me a true statement, right? I could do the same thing by going back in and substituting in the negative 4, all right? But I'm going to get two values here. Now, I want to draw your attention to that exponent right there. That tells me how many answers I should anticipate. Now, it is true that sometimes you're going to get two of the exact same answer, okay? But you still should get two answers on any quadratic equation. A quadratic equation is an equation that has a 2 as the highest exponent. So now let's come back down here and let's look at number 2 here. And I've got 5x squared minus 3x minus 2. So factoring is a little bit more difficult when this coefficient here is not a 1, and in this case it's a 5. So the method that I use here is to multiply the 5 times the negative 2 and get a negative 10. So I've got 1 and 10, 2 and 5. And one of these has to be negative because a positive times a negative is going to get me a negative 10 here. So keeping that in mind, I want to add those two factors together and get a negative 3. So it will be a positive 2 and a negative 5. So I'm going to separate this out. I'm going to put the 5's together. And I'm going to put the 2's together. Okay. So what we've done is we have separated out this term here. Okay. It's kind of like uncollecting like terms. So now using this method, which is, doing this by grouping, I'm going to factor out the GCF of the first term here, or the first two terms here, which is a 5x, and that leaves me with an x minus a 1. The GCF of the second two terms is a 2, and that leaves me with an x minus 1. And notice that my two factors inside the parentheses are the same. They're a common factor. So that's one of my factors. The other factor is the 5x plus the 2. All right. So now I am ready to use the zero product property, and I will get an answer of 1. And if I subtract the 2 over here and divide by the 5, I get a negative 2/5. So I've got two distinct answers here for this one. All right, and so this is doing this using the zero product property because we are able to factor these. So I will go ahead and switch colors here so that it won't end up looking all crazy. All right, so number 3. There's an issue with the way that number 3 is written because it's not equal to 0. Okay, notice over here I had a 0 parked over here to the right of the equal sign. So what we'll do is we will simply add the 3 over, and now we've got this equal to 0. Now, man, I'm saying the word now a lot. I guess that's my nervous word. The next thing that we're going to need to look at is this value right here. I'm not real comfortable factoring these when the leading coefficient here is a negative value. So what we're going to do is we're just going to multiply the entire equation by a negative 1, which takes care of that for us. Okay? So what we're going to do from here, notice I didn't say now, I had to concentrate on that. What we're going to do from here is I'm still going to multiply the 4 times the negative 3, and I get a negative 12. So my factors of 12 are like so. And I want one of them to be positive and one of them to be negative. And I want to be able to get a negative 1 when I add. So I've got a 4 and a 3. Okay. Now last time I went ahead and grouped the 4's and the 3's together. You don't have to do that. So let's not do it on this one. Okay. So now the GCF here is just an x, which leaves me with the 4x plus a 3. The GCF here, well, there isn't a common factor other than 1, okay? So that's what we're going to factor out is a negative 1. Why am I factoring out a negative 1? Because of that sign right there. Whenever the middle sign is negative, you factor out the negative version of the GCF. So again, notice that my two sets of parentheses are the same. So that is one of my factors. The other factor is the x minus the 1. And so if I set each of these two things equal to a 0 using the zero product property, I'm going to get an answer of a negative 3/4 and an answer of a 1. So these are my two answers to my quadratic equation. Now, in every single one of these, you could substitute these values back in to see if they are solutions by substituting them in for the x and then making sure that the original statement is true. I'm not going to bother going through that for all of these. I just wanted to highlight that that is what it means to be a solution. Okay. All right. So here, solve the quadratic equation using the square root property. So this is another one of the orange methods that are listed up here, which means that they do not always work. Notice that these are kind of all set up because we have a squared term, okay? So on number 1 here, I've got x squared equals a 36. And so if I want to solve this, I'm going to take the square root of 36. And so the square root of 36 is both a 6 and a negative 6. These are both solutions. So let me just really quickly talk to you about why the negative 6 is a solution. If I substitute the negative 6 back in for x, if I square a negative 6 times a negative 6, well, a negative times a negative is a positive, and 6 times 6 is 36. So it is, in fact, a solution because it results in a true statement. The other explanation could be that you could subtract the 36 across and factor by using the difference of two squares, but I don't think that we're going to go that far into it. Just understand that when you're using the square root property, you need to use both the positive and the negative version of the square root. So on number 2, I've got this x squared plus 32 here. So the first thing I'm going to do is I'm going to subtract the 32 across. All right. Let me tell you why I'm going to do that instead of trying to factor. On all of these, I had both an x squared and an x term. Okay. An x squared and an x term. So keep in mind that indicates that I'm probably going to try to factor, because I might not be able to, and I might not be using the square root property right off the bat. So now if I want to take the square root of both sides, you can see that I'm taking the square root of a negative number here. So I'm going to split 32, all right, so 32, 2 and 16, 8 and 4. All right, so I'm going to use 16. So this is a 16 times a negative 1 times a 2. So it will be the square root of 16 is 4. The square root of negative 1 is an I, rad 2. So that's one of my answers. The other answer is the negative version of that. Okay. All right, so it is possible that you're going to have complex solutions, okay, where you have had to take the square root of a negative number. So now let's look at number 13 here. Sorry, number 3. And on number 3, I've got a quantity that is squared equal to another value, okay? So my squared thing is by itself here. So I can go ahead and just take the square root of both sides, okay? The square root of the quantity 3x minus 1 squared is just 3x minus 1. If I want to simplify the square root of 12, well, 12 is 4 times 3, so it's 2 rad 3, and it's negative 2 rad 3. It's both versions, okay? So now, in order to completely solve this for x, I'm going to add 1 to both sides. And then divide by the 3. So here's my first answer. Okay, notice how similar the work is going to end up being over here. I'm going to add 1 across. And divide by 3. So I'm basically taking the exact same steps. And notice that these two things, my two solutions here, really only differ in the sign that's in the middle. One of them is a plus and one of them is a minus. So whenever you have either complex solutions like this, where we've got an I, or irrational solutions, you're going to have, that is going to be the only difference. These things are called conjugates of each other. Conjugate. All right. So I don't know that you necessarily need to know that term, but I wanted to just go ahead and give that to you. So on 4 here, all right, so I've got something squared equal to a value. This time it's equal to a negative value. So whenever I simplify this, this is going to be I rad 6. Okay, now keep in the back of your mind that it's also negative I rad 6, because I'm going to show you a little, I guess, I don't know, not a shortcut, but something to remember. So just keep that in mind, and I'll show you what I'm talking about next. So now, if I add the 4 across, it's going to be 4 plus I rad 6. Now remember, if the other answer was a negative I rad 6, then when I add the 4 over, it'll be 4 minus I rad 6. You see the similarity in those two solutions? Okay, one's got a plus in between it and one's got a minus in between it. So this is solving using the square root property. And the issue here is, not always are they going to be set up to where you can use this. Okay, now you can force it, which that is actually what we're going to learn next. That's called completing the square. So I'm going to come back up here. The two orange ones do not always work. Okay, they've got to be set up just right. You got to be able to factor it, or it's got to be set up to use the square root property. Completing the square in the quadratic formula, they will always work no matter what. Okay, but completing the square is, it can be pretty easy, but there are times, and we're going to see one here in a few minutes, where it's going to get pretty involved and get kind of crazy. So I usually will bail out to this. Okay, I almost never use completing the square unless I'm teaching it when I'm solving quadratic equations. But again, it is a skill that you will need when we start talking about circles and parabolas. So we'll talk about it. All right, where's the green here? All right, so on number 1 here, in order to complete the square, you need the coefficient of the x squared to be a 1. Now, in the first two, it is. In the third one, it's not. So I'll show you what to do when it's not a 1 when we get to this last one. So what we're going to do is I am going to take this 9 and I'm going to add it over to the right side. But notice the way that I'm going to write this. I'm going to leave a space here, okay? Because I'm going to add in something here, all right? How you complete the square is you take half of this value and you square it, okay? Now, since I added something on this side, I also have to add that value on this side, okay? Now here we can kind of put this on autopilot, okay? I'm going to leave some space here to explain something. This is going to factor to an x plus a 3 squared. That's the way that's going to work out, okay? Now why is that? Well, if I square that 3, that's x squared plus 6x plus 9. So what are the factors of 9 that add up to get me a 6? A 3 and a 3. Okay, which means that it's x plus 3 squared. Okay, because you have two of the same term. All right. Now over here, this is a 9, and so 9 plus 9 is now 18. Now this is set up for the square root property, but we had to do this process called completing the square first in order to get there. All right. So if I take the square root of both sides, the left side is going to be x plus 3. The right side, I can simplify this to 3 rad 2, which means that negative, ooh, that's terrible. Which means that negative 3 rad 2 is also an answer. Okay? But I've got to subtract this 3 across. Okay? So watch. It's going to be negative 3 plus 3 rad 2 and negative 3 minus 3 rad 2. These two answers are still conjugates of each other. Now, sometimes MATLAB will have the availability of a plus minus button, and so you might be able to type it in this way. Okay, but I wouldn't count on that. I don't think it's available on every problem. I think it's available on some, but not every single one. So let's not count on that. All right. So number 2 is going to be similar, but it's going to be just a little bit different. The process is going to be the same, but the mechanics are going to be different. I'm still going to take this 1 and I'm going to subtract it over. I'm still going to leave this space because I know I'm going to add in something here. The difference is when I go to add in something here, it's going to be half of negative 9, right? So I'm going to have a fraction here, which I think some of you just realized why I don't really use this method too often. So this is going to factor to x minus 9 over 2 squared. Okay. Over here on the right, if I square negative 9 halves, that's going to be 81 over a 4. So if I rewrite negative 1 as a fraction with the 4 as the denominator, it's going to be a negative 4 over 4. And so now the last step before we take the square root of both sides, negative 4 plus 81 is going to be a 77 over a 4. Now if I take the square root of both sides, on the left, I'm going to get the stuff inside the parentheses, the x minus the 9 halves. On the right, the square root of 77 I can't simplify. And it's going to be positive and negative of that. And the square root of 4 is 2. So now if I add this 9 halves across, it's going to be 9 halves plus and minus the square root of 77 over 2. Okay, this is one way you can write this. Another way you can write it is to go ahead and put all of, since there is a common denominator, you can write it this way. Okay? All right. So number 1, completing the square isn't that bad. Number 2, it's got fractions, so it's not real comfortable. It's not something that I would just necessarily love doing, but it's still manageable. Okay? Number 3, this is where it gets all sorts of crazy. Okay? Because what we've got here is a scenario where my leading coefficient is not a 1. All right. So in order to do that, to make it a 1, I've got to factor out the 2 from these first 2 terms. Okay, I'm going to go ahead and move the 3 over by subtracting it, but I'm going to factor out a 2 so that now this coefficient here is a 1. Now what I'm going to do is I'm going to, well, let me put this in a different color because I have been doing that. I'm going to take half of negative 3, and I'm going to square it. And I'm going to add it in on both sides. Now you might be wondering where this 2 comes from. Well, I'm not just adding in negative 3 over 2 squared. If I'm using my distributive property here, I'm adding in 2 of them. So you have to use this 2 in order to completely balance the equation. So this is going to be 2 times the quantity x minus 3 squared. Excuse me, sorry about that. Let's do some arithmetic here. This is a 9 over a 4. So then 2 times 9 over a 4 is going to be a 9 over a 2. And I want to rewrite negative 3 as a fraction with a 2 as its denominator. So let's see here. This will be a 3 over a 2. I cannot quite take the square root yet because this squared term still has this 2 by it, okay? So if I divide this over, dividing by 2 is the same thing as multiplying by 1/2. So now I've got 3 over 4. Now I can take the square root. The square root of 3 is something I can't simplify. The square root of 4 is a 2. And remember, I've got to have both the positive and the negative versions. Now, if I want to add this 3 over 2 across, my answer could look like this. 3 over 2 plus and minus the square root of 3 over 2. All right. So I hope that you see on this purple one, completing the square is crazy, okay? It is not a preferable way to do things, okay? It's going to be kind of nuts, all right? So let's go down to the last method that we're going to talk about today, which is solving a quadratic equation by using the quadratic formula. Where'd my quadratic formula go? Okay. The quadratic formula says if you have something set up in ax squared plus bx plus c form, then x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. That is the way that you can use the quadratic formula to solve a quadratic equation. All right. Let's start with number 1 here. So number 1 is actually going to be a little bit different because, let me move this up just a little bit. Because number 1, if you're solving this and paying attention, you can factor this one, okay? The factors of a negative 21 that add up to get me a positive 4 are a positive 7 and a negative 3, okay? So you would be able to factor this one. But let's pretend that you didn't recognize that, okay? So the coefficient here is a 1, so that means that the a value is a 1, the b value is a 4, and the c value is a negative 21. So if I am substituting into this quadratic formula right here, it's going to be negative b, whoops, it did it again. Negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. So the opposite of 4 is a negative 4. If I square 4, I get a 16. If I multiply negative 4 times 1, I get a negative 4. And then negative 4 times 21 is going to be a positive 84. Then in my denominator here, 2 times 1 is 2. Let's go ahead and do that one now then. Underneath the square root, if I add 16 and 84, I get a 100. Now notice right here that this is a perfect square. Okay? If you get a perfect square right there, what that means is your original trinomial is something that you could have factored. Okay? Doesn't mean you did anything wrong. It just means that you could have solved it using another way. It's not a big deal. So the square root of 100 is a 10. So I'm going to separate this out using the plus and minus sign. Okay, so it's 4 plus 10 divided by 2 and 4 minus 10 divided by 2. So, sorry, negative 4 plus 10 and negative 4 minus 10. I think I misspoke there. So negative 4 plus 10 is a 6, and 6 over 2 is a 3. Negative 4 minus 10 is a negative 14, and negative 14 divided by 2 is a negative 7. So there I get my two roots. All right. Now, a lot of times on these, you're not going to have to go this far because you're going to have a value underneath here that isn't going to be able to be taken the square root of. Okay. So let's slide down here. Let's look at number 2. And when we start number 2, we're going to see that we have an issue. It's not set up to where it's equal to a 0 here. Okay. So in order to do that, I'm going to subtract the 2x across and add the 5 across. Okay. Now I'm going to identify that A is a 1, B is a negative 2, and C is a 5, and I'm plugging back into this formula here, the quadratic formula. So x equals negative of b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Really, once you plug in these values, you're looking at a pretty complex order of operations problem where you've just got to do all of the arithmetic. Okay? So the opposite of a negative 2 here is a positive 2. If I square negative 2, I get 4. If I multiply negative 4 times 1, I get negative 4. If I multiply that times 5, I get a negative 20. And then 2 times 1 is a 2. Underneath the square root, 4 minus 20 is a negative 16. So the square root of negative 16, that's something I can take care of here, because the square root of negative 16 is a 4i. Now, they're not going to want your answer in this form, okay, because we've got a complex solution, which means we need to have it in the a plus bi standard form. So what I would say here is you can separate this out like this, but you can also simplify these fractions. So this will be a 1 plus and minus a 2i. Keep in mind that MathLab might want you to separate this out and write them separately. Okay, if you do not have the if you do not have the plus minus button available to you, then you're probably going to have to use something like that. Okay? All right. So -6 x squared equals 3x plus 2. I don't want to keep scrolling, so I know you guys are looking at number 4 thinking that it's going to be a nightmare. It's not. It's not going to be nearly as difficult as you think, because we're going to pull a trick here, okay? All right. So let's go back to that color. I kind of liked it. Okay, so this one is a -6x squared equals a 3x plus a 2. Wait, I am going to have to scroll back up. That was a plus 2, right? Yeah, it was. All right. Notice that I need to have one of these sides equal to 0, and I really don't like my squared term to have a negative coefficient. So I'm going to add the 6x across. And so this is what I'm looking at here. Okay, I've got an a that is a 6, a b that is a 3, and a c that is a 2. So now we're substituting back into that quadratic formula. The negative of b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. All right. So now it's arithmetic time. The opposite of 3 is a -3. If I square 3, I get 9. -4 times 6 is a -24, and -24 times a 2 is a -48. In the denominator, 2 times 6 is a 12. Underneath that square root, (9 minus 48 is a -39. So I can't simplify the square root of 39, but I can take out an I for the negative part, right? So taking the square root of a negative value is going to get you an imaginary or a complex value. All right, so remember, you don't want to write this way because you want to have it in that a plus bi form. So it's, you separate the fraction out, -3 over 12, and then the square root of 39 over 12, and then the I. Now, you can simplify that, okay? So it'll be a -1/4 plus and minus the square root of 39 over 12i. Okay? Not all of them are going to be this nasty, I promise. Okay? This really is a pretty efficient and fairly easy method to utilize. Oops. So let's look at number 4, the one that you've been just raring to go with. Okay. I don't know about you guys, but if I can get away with not substituting in an a of a 1/2 and a b of a 1/4, I would like to do that. So what I'm going to tell you to do is to identify the least common denominator between our two denominators. The least common denominator of 2 and 4 is a 4, and you should multiply the entire equation by a 4. And so when you distribute this here, notice what happens. You get a nice, neat looking equation that does not have a that does not have fractions. Okay. So now A is a 2, B is a 1, and C is a -12. That's going to be a heck of a lot easier for me to deal with. So the negative of B plus and minus the square root of b squared minus 4 times a times c all over 2 times a. All right? So the opposite of 1 is a negative 1. If I square 1, I get 1. Negative 4 times 2 is a negative 8. And negative 8 times 12, a negative 12 is a positive 96. And then in the denominator, 2 times 1 is 2. And this one is nice and easy because once I add those two things together, I'm not going to be able to simplify the square root of 97. We're finished right there. All right. So scrolling back up here one more time. The orange methods don't always work. We could not have used the orange methods on the last on the last 3 that we did. The green methods do always work, but this one can get kind of crazy. So I'm going to usually bail out and use the quadratic formula. Okay? All right. Now, while I'm scrolling down to this story problem here, I want you to understand that whenever you go to doing this on a test, if the directions explicitly say solve using completing the square, and you think that you would rather use a different method like the quadratic formula, I am completely fine with you doing that. Okay? Keep that in mind. I'm not going to force you to use that completing the square method. Okay. So then we're going to have some applications. An ecology center wants to set up an experimental garden using 300 meters of fencing to enclose a rectangular area of 5,000 meters squared. Okay, so really what we've got here is a perimeter that needs to be 300. Now, if I know that both of my widths here are going to be an x, then that means that both of my lengths here are going to be 150 minus x. Okay? We'll talk about the mathematics of that here in just a moment once we get the value of x. The other thing that we know is that we've got an area here of 5,000 square meters. Okay? Area for a rectangle is length times width. So if I substitute 5,000 in for the area here, and I substitute in 150 minus x for the length and x for the width, then I can solve this equation because I only have one variable here. So we're going to begin by distributing. So I get 5,000 equals 150x minus x squared. So I think I'm going to try to factor this, which means I need it equal to 0. I also would prefer for this to be a positive coefficient. So I'm going to move those two things over. I'm going to add the x squared over and subtract the 150 over. Okay. So now I'm looking for factors of 5,000. They're going to add up to a negative 150. Okay. So 1 and 5,000, 2 and 2,500, 4 and 1,250, 8 and, oh good night, what is that? 1250 divided by 2 is going to be 625. Oops, 25. So let's go with 5 and 1,000. That'll be 10 and 500. That'll be 20 and 250. That will be 40 and 125. Still not quite there. What about, I could do 50 and 100. Ah, there we are right there. So it's going to be x minus 50 and x minus 100. Now, as I was going through that list of factors, if you are thinking, I don't think I can find factors, guess what? Go up here and use the quadratic formula and you'll be able to solve it, okay? You're going to be able to take this square root once you get to this point, and you'll be able to get down to 2 solid answers, okay? All right, so now if I set each of these equal to 0, I'm going to get 2 answers here, which might seem a little fishy, okay? Okay, so let's talk about this answer here of 50. So if I have a perimeter of 300 and I have 2 lengths and 2 widths, okay, well, if x is my width, right, that means that I've got 50 here and 50 here. Okay, so 50 what? 50 meters here. So I have a total of 300 meters of I have a total of 300 meters of fencing, and I've used up 100 of it, which means that I have 200 left over. Well, if I've got 200 left over, that means that there's 100 meters left for each length. Okay? So now let's talk about this one. Well, I still only have 300 meters of fencing. I got 2 lengths, and I got 2 widths, but now my widths are 100. So that's 200 of my 300 meters of fencing, meaning I have 100 left over, which still gets us to these same dimensions here, okay? So look at what the prompt asked us for. The prompt says find the dimensions of the garden. It's going to be 50 meters by 100 meters. And it doesn't really matter which one of those answers you use. You're still going to get the same dimensions. All right? Okay, so here's this video. I apologize for my 8:30 class. That's where I started having all of my technical difficulties, and then I started doing problems wrong, and it was a hot mess. And then for my 11 o'clock class, I canceled because of the difficulties that I was having, and I needed to take some time to overcome those. So I will be posting this video for you guys, and I will see you tomorrow. See you Thursday.